Okay, section 5.3, part 2, continuing on with our definite integrals and antiderivatives. So the derivative of an integral is a function f of x. We are going to do some work in class to show how we get to this. So for right now, just copy it down. So if the derivative of the integral is another function, that means that this function is the antiderivative of f of t. So let's look at what that means to us. So if f, and I'm using a capital F here to distinguish, is any antiderivative of f, then the integral from a to x of f of t dt, notice I have to use different variables, we'll talk about that as well, then that equals the antiderivative plus c for some constant. Remember we said that there are many antiderivatives for any function, and plus c distinguishes them from each other. Now I'm going to do a little bit of manipulation with this. Set x equal to a to get the integral from a to a of f of t dt equals the antiderivative at a plus some constant c. Now we learned in our rules that if I take the integral from a to a, that's simply 0. So 0 equals my antiderivative at a plus some constant. So what does the constant equal? The constant equals negative f of a. So now I have a value for c. I'm going to plug that back into my original. So the integral from a to x of f of t dt is the antiderivative evaluated at x minus the antiderivative evaluated at a. This is really important. We're going to spend a lot of time on it. For right now, we're just going to use it. And as I said, we'll do some preliminary to this when we get into class. But let's try one example. So find the integral from 0 to pi of sine x dx. So I'm going to use this model that we had, which is the integral from a to x of f of t dt equals the antiderivative evaluated at x minus the antiderivative evaluated at a. So let's use our problem, 0 to pi of sine x dx. You notice I've gone back to x because I now don't have a variable in my limits of integration. What is the antiderivative of sine x? Hopefully remember that it's negative cos of x, in this case, the top limit of integration, minus negative cos of 0. So that's following my model. Notice I put a parenthesis so that the minus from my equation didn't get lost with the minus of my antiderivative. So I've got negative cos of pi plus cos of 0. Whoops, that's just a 0. The cos of pi is negative 1. The cos of 0 is positive 1. So this equals 2. So the integral, or the area under the curve from 0 to pi of sine x is 2 units. Okay, so pretty easy to calculate. We're going to do some more of this in class, and as I said, we're going to do a little bit of explanation of how we came up with that first equation to begin with. The following slides are some quiz questions. If you want to keep these, you might want to use them as you review for our quiz, or as you work on your take-home quiz, or if you just want some extra practice problems. So I'll scroll through them for you. Sorry, this should all be 5.1 to 5.3. Don't worry about that. So there's number 2 answer, question 3, and that's it.